Welcome to part 1 of the dimensional analysis topic. In this video, we'll get introduced to English and metric units of measurement. We're going to talk about common prefixes used for metric units. We'll learn about equalities, or equivalent or equivalence statements that play a key role in setting up conversion factors. In conversion factors, that's what we use for converting from one unit to another. So measurement is a quantitative way to describe a physical object or event. Measurements consist of a number or value and a unit. For example, newborn babies are commonly measured to determine their weight and length at the time of birth. As you can see, all these measurements consist of a number and a unit. For example, we can say that weight of a baby is 8 pounds, 8 ounces, or length of a baby is 21 centimeters. 21 is the number or value, and then centimeters represent units. Here you can also see how both weight and length are expressed using two different types of units. One of them is English units, and another one is metric units. Let's talk more about those two systems of measurement. The United States uses the English system of units. This table provides English units used for measuring length, mass, and volume, along with the symbols used for those units. For example, English units of length inches are commonly denoted by IN, or units of mass pounds are denoted by letters LB. Well, most other countries, as well as scientists around the world, use the metric system of measurement. And modification of the metric system, called the International System of Units, or SI, is considered to be the official system of measurement used throughout the world. The base metric units used for measuring length, volume, mass, and time are shown in this table, along with their symbols. M for meters, uppercase L for liters, G for grams, and an S for seconds. One of the advantages of metric units is that they're based on factors of 10, or we can say powers of 10. And this is how scientific notation for each of those values is obtained. We can write each number as a power of 10. And the shortcut for determining the power of 10 for large numbers is simply counting how many zeros we have in that number. So here we have 1, 2, 3 zeros, that's 1,000, and that corresponds to 10 power 3. 9 zeros in a billion, it's scientific notation 10 to the 9th power. As you can see, small numbers, 10th, 100th, and so on, have negative powers of 10. To determine the power, you simply need to count the number of decimal places. In other words, number of digits that follow decimal point. Here we have 1, 2, 3 decimal places, so power of 10 is -3. So again, positive powers of 10 represent large quantities, and the negative powers of 10 represent small quantities. And this is how these numerical values are used in metric system. Each of those numbers has a name, or it's called prefix, and the corresponding symbol. And this allows us to create many different units out of base units that we saw on the previous slide. Let me give you an example. Let's say I'm given this measurement in metric units, 1,000 grams. I could also write G instead of grams. From this table, I can see how the numerical value 1,000 corresponds to the prefix kilo. So this allows me to replace 1,000, large quantity, with prefix kilo and obtain another metric unit, kilogram. Its symbol is kg, K for kilo. Let's try another example. What if now I have a small quantity, let's say 0.001 grams? Well, that's thousandth. From this table, I can see how thousandth correspond to prefix milli. And this allows me to rewrite the original quantity as 1 milligram, which is denoted by mg. M stands for milli. So overall, prefixes used in metric system allow us to indicate and express the magnitude of a quantity. Giga, mega, and kilo are prefixes used for large quantities. And deci, centi, milli, micro, nano are the prefixes used to represent small quantities. If you take any food item packaged in the United States and look at the nutrition facts label, you will find that daily value nutrient requirements are expressed using metric prefixes. For example, here we can see mg for milligrams, and here mcg for micrograms. Let's try a few more examples using this table of common prefixes. This time I'm going to start with a unit that contains a prefix, 1 kilometer. This table reminds me that prefix kilo corresponds to the numerical value 1000. So I can rewrite 1 kilometer as 1000 meters. In other words, 1 kilometer is the same as 1000 meters. That's why I can put equal sign between them. And what we're looking at is called an equality, or an equivalence statement, or we can also say equivalence statement. But overall, it means that we can express the same measured amount using two different units. In this case, it's kilometers and meters. Let's try obtain another equivalent statement. This time I'm going to start with 1 centigram. This table reminds me that prefix centi corresponds to numerical value 0.01, that's 1/100th. That can also be written as 10 to the power negative 2 using scientific notation. Therefore, I am able to rewrite 1 centigram as 10 to the power negative 2 grams. And this is another example of equality or equivalence statement. Once again, equalities use two different units to describe the same measured amounts. This is one of the equalities we just saw. 1 kilometer is the same as 1000 meters. But when it comes to equalities, it doesn't matter on which side I put which units. So the same equality can be written as 1000 meters equal to 1 kilometer. These two equalities are equivalent. And by the way, notice how while this equality use two different units, both of them are metric units. Metric to metric. We can also set up equalities that relate English units, English to English. For example, 1 foot is equivalent to 12 inches, or 12 inches is equivalent to 1 foot. But there are also equalities that relate English and metric units. This equality indicates how 1 pound, which is English unit, is equivalent or equal to 454 grams, which is a metric unit. Some measuring cups used for medicine give us examples of English to metric equalities. And while we use prefixes to obtain metric to metric equalities, when it comes to English units and metric English unit relationships, we need to rely on tables to determine correct equalities. You may have noticed that in the United States, the contents of many packaged foods are listed in both English and metric units. But how do we convert between two different units? For example, how do we know that 8 ounces is equivalent to 227 grams? Well, for that, we need to use what's called conversion factors. Conversion factors are simply fractions written based on equalities. For example, if we take the equality 60 minutes equal to 1 hour, then we can write the following two equivalent ratios or fractions, either 60 minutes over 1 hour or 1 hour over 60 minutes. Recall that the top number of any fraction is called the numerator, and the bottom number is called the denominator. Let's try another example. This time we're going to use this metric equality. 1 meter is equal to 100 centimeters. This equality, or equivalent statement, produces two conversion factors, 1 meter over 100 centimeters and then 100 centimeters over 1 meter. It's important to note that in some cases a conversion factor may only apply to the given problem. For example, it can be given that the car was traveling at 85 kilometers per hour. Based on the given information, we can write down the following equality, 85 kilometers equal to 1 hour. It relates the distance traveled by the car in 1 unit of time. And based on this equality, this will be the two conversion factors, 85 kilometers over 1 hour and then 1 hour over 85 kilometers. Here's one more example. 1 tablet contains 500 milligrams of vitamin C. What kind of equality can we write down based on the given information? Well, it can be written this way. 1 tablet equals to 500 milligrams. And these are the two corresponding conversion factors. As you can see, these conversion factors were not obtained using the tables of commonly used units. Instead, they were obtained from the information given in each problem. Let's extend what we just talked about to the example that provides certain medication dosage that also can be written as conversion factors. In this example, it says that Caflex, or cephalexin, an antibiotic used for respiratory and ear infections, is available in 250 milligram capsules. In other words, we're given that one capsule contains or equal to 250 milligrams of the given drug. And from this equality, we can produce two equivalent conversion factors that will be essential in computing medication dosage. Finally, let's see how percentages stated within the problem could also be written as conversion factors. A conversion factor obtained from a percentage represents the ratio of the parts to the whole, where the value that we use to represent the whole will be always 100%. And we'll always need to use same units in the numerator and denominator. Let's give it a try. In this example, it says that a person might have 18% body fat by mass. We're also provided with a little bit of information explaining what it means. It says that the thickness of the skin fold at the abdomen is used to determine the percentage of body fat. But let's go back to the first sentence. 18% body fat by mass can be written as the following equality or equivalent statement. 18 kilogram body fat, that came from 18%, that's the part. And then 100 kilogram body mass, that represents the whole. Notice how we're using same units, kilograms, kilograms. By the way, in this problem, the units were not noted, so we chose commonly used metric units for measuring body mass. They're kilograms. And these are the two conversion factors that can be produced from the equality.